So Emily Waring holds a Bachelor of Science from University of Nebraska-Lincoln in Biological Systems Engineering and a PhD and Master's in Agricultural and Biosystems Engineering from Iowa State University, where her research focused on managing nitrogen loss from fields through practices such as cover crops, fertilizer management, and no-tillage. Upon graduating, she came to California, where we were happy to have her, to expand her knowledge base to water-stressed system areas with more diverse cropping systems, where she joined the Secure Water Future Project as a postdoctoral scholar. Now in the position of research coordinator at the Experimental Smart Farm at the University of California, Merced, Emily supports faculty, staff, and students in experimental design, fieldwork collection, and data management. Thanks, Emily.
Thank you. So I'm realizing that I did not put alfalfa in my title, but to be clear, this talk is about alfalfa. So this is pretty exciting. I'm currently pushing forward a paper about advertising or demonstrating the flexibility of alfalfa. And these are my co-authors. We haven't submitted the draft yet, so looking forward to talking to people after this, what you think about stuff. Maybe we'll change stuff based on this conference. So for some background on alfalfa, it is often criticized or highlighted in the media as a thirsty crop. And so we're in California, most of us, and we're thinking about things possibly from a groundwater sustainability agency perspective where someone might have to make a decision to fallow some land. So in order to save water. So that's the background behind focusing on the depth of water use. So there's more flexibility in alfalfa, of course, because there's multiple cuttings. And then when we look at this depth of water use in Tulare County, alfalfa is the highest, and then it's followed by citrus and nuts. So when we think about alfalfa and the possible flexibility there compared to some of these crops that require higher capital and don't respond well to deficit irrigation, we're trying to highlight and emphasize that this could be a possible water management tool that may not work with our current structures, but still trying to highlight the potential here. So there's also a narrative that alfalfa is a good crop for drought, and that's because of this relationship between water use and revenue from multiple cuttings. So if you look at the white dots there, it's the ET requirement, and then again, we're showing an example from Tulare County where the black diamonds show the revenue per ton. So as the ET requirement is going up, the revenue per cutting is going down. So it could be a win-win situation where a grower could possibly sell their water and stop applying. So we're using the phrase summer deficit irrigation here, and we mean basically shutting off the tap in July, getting a harvest in July, and then no longer watering after that. So to show this potential, we needed monthly water use at a large scale, and as we've been talking about, there's skepticism of using remote sensing data for alfalfa. But enter OpenET and Nick Santos. We just decided to try it anyway, pretty much. So for most of the graphs today, I'm specifically highlighting a HUC 8, which is 1810-0204, which is down in Imperial County. So the first thing that we noticed is when we were trying to define our polygons to basically figure out where the alfalfa was, that cropland data layer was like way overestimating the alfalfa area. So to get our field boundaries, we only kept a pixel if it was in CDL, or if CDL had classified it as alfalfa for all 3 years of interest. And that got us down to much more realistic numbers compared to the census data. And then to remove edges in smaller fields that we suspected were misclassified, Nick used focal stats and shrink, which left only fields that were beginning at 1.5 acres or more. And then we input those field boundaries into Google Earth Engine and got a mean for each field. And here I'm comparing some select models that we've been talking about. So this, again, is just for this particular Huck 8 in Southern California. And I want to highlight, okay, on the right there is the county estimate, and that is from California Department of Water Resources, and they use CalCIMMET AW, which is based off of crop coefficients. But we're kind of using that as like a check, and then I'm comparing ET ensemble, metric, and CBOP, and then we're just showing that ET, the remotely sensed models are under predicting compared to the county average by California Department of Water Resources. And I just wanted to look at when the models agree versus disagree. So here I plotted standard deviation by field size, and you can see that as the fields get bigger, the models tend to agree more. And someone in this room could probably tell me why, but I just thought maybe they're more likely to be classified as alfalfa if they're bigger, or just more likely to be uniform if they're bigger. And then, yeah, to address some of the skepticism around using remote sensing data to estimate alfalfa, we compared to some on-site studies, but I put an apple and an orange here because we are comparing different years. So I realize this table isn't full yet. It's on the next slide. But I just wanted to demonstrate that we're looking at 4 different sites here: Scott Valley in California, which has 3 cuttings each year; Mesilla Valley in New Mexico, which has 6; San Joaquin Valley, which has 8; and then Imperial Valley, which has 9 or more. And those are the years of the available data there. So that third line, or the second line of numbers there, is the ET ensemble of that particular Huck 8 based on the alfalfa field boundaries that we had previously defined. And then the ET actual is those ground truth data, or case studies, published studies. And basically we did find that it's consistently, or OpenET ensemble is consistently reporting lower than the ground truth data, but that it is consistent across regions and only 10 to 30%. And so some of our co-authors are extension professionals that have worked in alfalfa for their entire careers, and they're skeptical of remote sensing data, and I've just found that the way that they communicate that is just like, what's your KC? Like, they don't care about really anything. They just want to know what's your KC. So that's how I'm now presenting this data to some people. And basically, literature reports a range of KC for alfalfa from 0.8 to 0.1 for most active growing months. That's a California study. And our results range from 0.6 to 0.7. And this particular graph is actually the entire Southwest. But I am showing the first half of the year crop coefficient, the second half of the year crop coefficient, and then the annual crop coefficient. And the last 2 groups, so where we're predicting 7 to 8 cuts or 9+ cuts, you can see that there's a dip in the second half of the year in the KC, which to me, I think gives a little bit of credibility to this approach, because I think that would reflect reality where ET requirement is not able to be supplemented by irrigation. So my main conclusion is that we did use monthly OpenET ensemble data to demonstrate partial year water savings at a large scale. And even though it may be underestimating, it was useful to evaluate alfalfa at a large scale and even if our conclusions have the caveat that they are conservative or possibly underestimating. And like we've been talking about, ensemble estimations were lower than the case studies, although they were not direct year-to-year comparisons. But some possible explanations, I was thinking ensemble may not be the best option, or that we are more likely to predict an artificially low evapotranspiration because of a variable KC through a shorter harvest cycle, which other people have brought up, or that many field sites are actually lower than optimally irrigated than the experimental sites we were comparing them to. So the fact that we're accessing so many field sites may increase our chance of capturing them. And that is all.
Thanks, Emily.
Hi, great talk. Love your concept. Just a quick question. On your KCs, are you using grass reference or alfalfa reference?
Grass reference.
Okay, thanks.
Yeah. I know.
Thank you for that very nice analysis. On the field size issue, it is good to recall that the Landsat thermal pixels are on the order of 2.5 acres just by themselves. It's 100 meters by 100 meters. So I think generally for the thermal models, the recommendation is to have and especially considering possible misalignments between smaller fields and the pixel grid. I think the general recommendation there is to have fields probably to take anything less than a 5 to 10 acre, probably more like a 10 acre field, a little bit with a grain of salt, and we will be discussing that a bit tomorrow at the workshop that's being held tomorrow, and Rick and Aisha are going to be at that, and they have they're definitely kind of the experts in that area. But yeah, so pixel resolution is something to keep in mind.
Yeah, you can see there's a little bit of a cliff at like 5 pixels, or I guess it really drops off in the sense of they start to agree more pretty quickly there. So I think that supports what you're saying.
See if I can get back there without knocking over a table.
Yeah, have you been able to share these results at all with folks in the Imperial Valley, and how were those received?
Not in Imperial Valley. I spoke at an event in Tulare, and they were really, it resonated a lot that, okay, a little bit of context. Tulare is just a little bit up farther, or a little bit north of Imperial Valley. And there's a different culture there. So I am not sure how this would be received in Imperial Valley, but in Tulare, they were excited to see that there was sort of like a different lens being highlighted on alfalfa, and then they were also very excited about bird habitat. There's a lot of migratory birds that can only stop in Tulare in alfalfa fields on their way to the Merced bird reserve. So they were excited because it's sort of like a pro-ag angle, you know, so they were excited about that. But yeah.
Yeah, there was that article, I don't know if you saw in ProPublica, about the 20 families in Imperial. So I don't think that was super well received in the valley. So anyhow, I was going to give you a badge of honor for going to talk to them directly, but
Not yet.
yeah, good luck.
So, and you may have said it, I may have missed it, I'm not sure. Are you going to use OpenET to look at alfalfa fields that are deficit irrigated, or like you mentioned about like July 1 shutoff or July 31st for a shutoff? Are you going to do any work with that?
Yeah, so this presentation is all about my methods and not about the actual conclusions of the paper. The conclusions of the paper are we took the July to October monthly OpenET data and then we analyzed the potential of that for water savings. So the practicality of how that could actually be applied, we'll discuss, but we're just looking at basically how much water is used in the second half of the year, and then, or from July to October, and then what is the economic impact of taking out that, or forfeiting that alfalfa revenue. So it's more like a economics water use angle. No, there are a few, like Montazar, I don't know if he's here, but he has a few like ground truth studies where he is analyzing deficit irrigation fields.
Question here, Josh Fisher here. This follows on Ted's comment about sharing results and just results that you might have questions with, especially with the models. And this is a comment for really everyone working with OpenET. By all means, send weird figures and graphs to us at the tech team. We meet weekly. We can give you quick answers or long answers, but we are a resource for you guys if you're just wondering what's going on with the models, with the data, and we can be like, oh yeah, this is probably what's going on with this model or that. So feel free to lean on us. Don't hesitate to reach out. Stupid questions, complex questions, whatever it is. And so that comment's for everybody.
Thanks.
Last question here.
Rick Allen, formerly from Idaho. Some past studies on deficit irrigation of alfalfa in California and Utah back in the 90s showed that once you shut off irrigation to alfalfa, it can take 2 to 3 years for it to extract all the stored moisture in the root zone, clear down to 3 meters at times. So it's not an on-off switch. So management-wise, what's the strategy to try to get good production and keep a healthy crop during the first half of the year, but then try to encourage that alfalfa to say when and reduce its ET?
Yes. Well, okay, so part of the reason that part of our approach is we're defining water savings, or what a grower may be compensated for, as applied water, not necessarily water use, which is a heck of an assumption itself. But in terms of alfalfa management, I think that I hear you that the alfalfa is going to keep using the water in the profile. So our economic model is also conservative in that way, in that we're assuming that they actually don't get any more cuts that entire year. So it's sort of like we're being conservative on the ET estimations, but we're also being conservative on the economics. And I don't think, like, I am, we are explicitly not trying to oversimplify this or say, like, this is, so easy for a farmer to do or something like that. We're trying to show the large scale potential impact and then let other people figure that part out.
Wonderful. Thank you, Emily.
Thank you.